morning, sir.
Good morning, guys. Welcome to the day 4 of the organic chemistry class, chapter 8. Today is 2nd of September 2021. So, in the previous class, I was talking about homologous series, alkanes, alkenes, and alkynes. Okay. Now, today also, I'll be talking about the homologous series in details. Okay. Now, homologous series. The ability of carbon atoms to form chains, this ability, which is called catenation, leads to the existence of a series of compounds that have the same functional group and they have similar chemical properties. Okay. Only differ from each other by presence of an additional carbon atom and its two associated hydrogen atoms, which is a CH2 group in the molecule, which causes the physical property to change in a regular manner. Now, homologous series, a series of compounds related in this way is said to form a homologous series. The alkenes are the simplest example of such a series, but others include the alkenes, the alcohols, and the carboxylic acids are also different homologous series. Now, this series can be thought of as different families of organic compounds. They are different families. Like alkane is a family. Alkane is a family. Then we have alkene as another family, another homologous series. Then we have alkynes, another homologous series. Then we can have aldehydes, aldehydes. Okay, we can have ketones.
Alcohol,
We can have ketones.
alcohol,
We can have alcohols. Okay, we can have carboxylic acid. Okay, we can have after carboxylic acid amides. There are so many. So these are all families. Okay, and each family is called in this scientific term, which is called homologous series. Okay, now moving to the next slide, you can see over there the homologous series of hydrocarbons, which are alkanes with the general formula CnH2n plus 2. The first good example of an alkane is given ethane, 2 carbon atoms with 6 hydrogen atoms. The next homologous series of hydrocarbon is alkenes. General formula is CnH2n. An example is given ethene. There should be a double bond. There is a double bond over here and 4 hydrogen atoms on the 2 carbons. The third homologous series is alkynes with the general formula CnH2n minus 2. The example is ethyne. Carbon-carbon triple bond is there. Okay. Now, further, with regard to the characteristics of a homologous series, all members of the series can be represented by the same general formula. They will obey the same general formula of a particular homologous series. Each member of the series differ from the members before or after by a CH2 group, by CH2, one carbon atom and 2 hydrogen atoms. Like for example, if I'm talking about ethane, ethane has formula C2H6 and methane has formula CH4. If I subtract them mathematically, I will be left with 6 minus 4 is 2. So hydrogen 2, carbon 2 minus carbon 1 is 1 carbon. So that is a group. So the successive members differ by a CH2 group. All members of the series, homologous series, they possess similar chemical properties. Their properties are similar. Okay. All members of the series show a gradual change in their physical properties as their molecular mass increases. So there is a gradual, nice change in their physical properties because of what? Because of the increasing molecular masses. In general, as molecular masses increase, melting point or boiling point and density will also increase. So these are some characteristics of homologous series which you need to read once. Okay. Now, nextly, these things I've already shown you in the previous classes, but even then, once more, I want to revise it. The molecular formula is the first column. So molecular formula for ethane is this one, C2H6. Its structural formula is C2H6 over here. This formula is called structural formula. It's open. And then if I write this same structural formula in a condensed manner, the formula is now called condensed. It is called condensed structural formula. It is called condensed structural formula. Okay. Now if you look at the molecular formula of ethanol, it is C2H6O. Okay. The structural formula is here, and this one is the condensed structural formula. The next one is propane. Molecular formula of propane is C3H8. 6 plus 2 is 8. The structural formula is C3H8. Okay. And the condensed structural formula is CH3CH2CH3. So I want to make this point clear between molecular formula, structural formula, and condensed structural formula. Okay, so remember, while writing IUPAC names of organic compounds, it is advised to students to always try to draw the structural formula, because from the structural formula it becomes very easy to write down the IUPAC names of organic compounds. Next slide. Alkenes. Look at this slide very carefully. Alkenes, saturated. All carbon atoms hold the highest allowed amount of hydrogen atoms. General formula is CnH2n plus 2. Type of bonding is contains all single carbon to hydrogen bonds or carbon to carbon bonds, and they end with a suffix an. The suffix is n. The simplest structure of an alkane is methane. It is methane. The next one is alkenes. The second homologous series of hydrocarbons, alkenes, are unsaturated. Means we can add something more over there. A carbon atoms do not hold the highest allowed amount of hydrogen bond atom because there is a multiple bond. General formula is CnH2n and contains at least one carbon to carbon double bond. Here contains all carbon to carbon single bonds. Here at least one carbon to carbon double bond. The alkanes end with the suffix in, and the simplest structure of an alkene, that is ethene, is given over here, C2H4. Okay. The next homologous series of hydrocarbons is alkynes. It is what? Alkynes. Alkynes are also unsaturated. General formula is CnH2n minus 2. Okay. Now alkynes contain at least one carbon to carbon triple bond is there. It is compulsory. Now alkynes end with the suffix "ine", sometimes referred to as acetylenes also. Alkynes are also called what? They are also called acetylines. They are also called acetylines. Can you hear me, boys? Can you hear me?
Yes, sir.
So
Yes,
alkynes
sir.
are also called acetylines. Acetylines.
Yes,
Reactivity
sir.
is very high. Acetylines have very high reactivity. Okay. So they are called acetylines also. Alkenes are commonly called paraffins. Parafins. Paraffins means less reactive. Alkenes are called olefins. Olefins. Olefins means oil forming. And alkynes are called acetylenes because of their high reactivity. Because of their high reactivity amongst these
Alkyne oil forming means like petrol and all.
alkenes, not petroleum and all. They are oil forming. They are oil like. Okay, they form oils when they react with some other elements or compound. Okay, oil forming. Okay, so this was one classification to make you understand. Now, moving to the next slide, look at the alkanes on this chart over here very carefully. You will see that over here, the first column contains the alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Their molecular formula is this: CH4, C2H6, C3H8, C4H10, C5H12, C6H14, C7H16, C8H18, C9H20, and C10H22. And these are the condensed structural formula. Okay. Now, isomers not possible for methane. Ethane also isomers not possible. Propane also isomers not possible, but butane 2 isomers are possible. Pentane 3 isomers are possible, and it goes on increasing 5, 9, 18, 35, 75. So isomers in the case of alkanes are possible from 4 carbon atoms when the value of n is equal to 4 and above. Isomers are possible only in these cases. Okay. Now, moving to the next slide, you need to learn this. Okay, you need to learn these word roots. You need to learn this properly. Okay. If the number of carbon atoms is 1, the word root is meth. It is meth. It is meth. M-E-T-H. Meth. Then, if there are 2 carbon atoms in the organic compound, the word root is eth. It is eth. If there are 3 carbon atoms, the word root is prop. If there are 4 carbon atoms, the word root is but, not but. It is but. But. If there are 5 carbon atoms, the word root is pent. If there are 6 carbon atoms, the word root is hex. For 7, it is hept. For 8, it is oct. For 9 carbon atoms, the word root is non. And for 10 carbon atoms, the word root is dec. Okay. So you have to learn this table 11.3 on your screen. Okay, on this slide. Now, meth, eth, prop, but, pent, hex, hept, oct, non, dec. Learn it as if you are learning, the months of a year, okay, or the days of a week. That way, okay. Learn it by heart. After that, look at the next slide. Again, there might be some students who might ask, what is the number of carbon atoms if an organic compound has 11 carbon atoms? What is it called? So for them, I've got from 11 to 40 over here. Okay, just for information only, not for learning purpose. This is not for learning purpose. Okay, only this is for learning purpose. Okay, now let us go to the main part of this chapter, which is called nomenclature. While writing the IUPAC name of a compound, the first thing which should come to your mind is word root. The second thing that should come to your mind is primary suffix. The third thing that should come to your mind is secondary suffix. And the last one is prefix, which should come to your mind. Now, this one, I am going to write it in correct order. Number one is word root. Word root is number of carbon atoms. The word root tells us about number of carbon atoms in the organic compound. This tells us about number of carbon atoms in the organic compound. Number of carbon atoms in the organic compound. Okay, that is the word root. Okay, then after word root, as I have told you, the next thing is number 2 over here. I'm going to write over here number 2. The next thing is called primary suffix. So I'll write over here primary suffix, P-R-I-M-A-R-Y. Primary suffix, S-U-F-F-I-X. Primary suffix. Now, what information does the primary suffix gives us? It tells us about saturation and unsaturation, which means it tells us about single bonds. It tells us about single bonds or double bonds, or presence of triple bond in the organic compound. If there are single bonds, all carbon single bonds, then at the end the suffix we write it as ane. If there are double bonds, we write the suffix ene. If there are triple bonds, if there is a triple bond, then we write in the suffix primary suffix yne. So this is the information provided by whom? By primary suffix. After the primary suffix, we have number 3, next one, number 3, which is called secondary suffix. secondary suffix, secondary, suffix, secondary suffix. Now the secondary suffix tells us about the functional group, the functional group. Which functional group is there? It tells us about the presence of the functional group. If there is an alcohol, then you will find OH. Okay, alcohols, the secondary suffix written as OL, all. If there is an aldehyde, then you will find like this CHO. Then we write AL. If there is a ketone, then you will have like this group in the organic compound, which is written as ONE, on, not one, on. If there is a carboxylic acid, then you will find groups like this COH. This is acid group, carboxylic acid. Okay, so the secondary suffix tells us about the presence of functional groups in the organic compound. After number 3, secondary suffix, we have before the word root number 4, which is called prefix, prefix. Now the prefix tells us about any other side chain branching by alkyl groups. Now what are alkyl groups? Alkyl groups are like this. It can be methyl group, it can be ethyl group, C2H5 group, it can be C3H7. This is propyl group. So if there are alkyl groups branching the chain of that organic compound, then the naming of those branching groups comes under prefix. So any other side chain branching by alkyl groups, or the presence of halogens, like halogens can be fluorine. If there is fluorine, chlorine, bromine,
So
iodine.
can you repeat again this
Which
prefix?
one? Prefix. In the prefix tells us about any other side chain branching. If there is a side chain in the carbon-carbon chain, if there is a carbon-carbon chain like this, long chain is there, and somewhere suddenly there is a branching over here, and there is a methyl group. So this is an alkyl group, no? So whenever there is any branching by a methyl group or a halogen, if there is a halogen, say, among this fluorine, bromine, iodine, if there is a fluorine, this is also a branching. So this branching, naming of these branched groups, it comes under prefix. So if there is a fluorine atom, we call it fluoro. Fluoro, fluoro. If there is a chlorine, we call it chloro. If there is a bromine, we call it bromo. Bromo, bromo. Don't say Bruno, okay? If there is I, then we call it iodo. Okay, so this is how we work on the naming of organic compound. This is a very important slide on the screen for you. While naming organic compounds, first you work out the word root. After the word root, right hand side, work out the primary suffix, check the single, double or triple bonds, and accordingly write in, ein wherever necessary. Then you work out the secondary suffix. How? By looking at which functional group is there, whether it is an alcohol or an aldehyde or a ketone or a carboxylic acid. Okay, and write accordingly. After that, only come to the prefix and see if there are any branching on the chain, carbon-carbon chain, by an alkyl group or halogens, and that will be named under the prefix. Okay, now to make you understand this more properly, I will do one example. By introducing one slide over here. Okay, I'll introduce one slide so that the picture becomes clear on your mind. Okay, so the IUPAC nomenclature, here we are on the next slide. I'm getting the slide ready for all of you. Okay, now have a look very carefully, my dear boys of class 10 A, B, and C. So one example, I've got an organic compound writing on the screen. I'm writing an organic compound on the screen. Okay, CH3, CH2, CH3, okay, CH, then I will put over here, say CH3, then here CH3, okay. So this is the organic compound whose IUPAC name I am supposed to write, IUPAC name. So one by one, the first thing which I must do is number the carbon atoms. Listen very, very carefully. Number the carbon atoms along the straight chain. So if I number the carbon atoms from here, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, then it is wrong. It is wrong. I cannot number the carbon atoms from this carbon, the left hand side carbon, because the branching methyl group is far away from this carbon. It is far away. It is far away. Okay, so I'll number from the other end. So it is very important to number the carbon atoms in such a manner that branching by an alkyl group or halogens or presence of a multiple bond is closer to the terminal carbons. This carbon is a terminal carbon. This carbon is a terminal carbon. So whichever terminal carbon is closer to a branching by an alkyl group or a halogen or a multiple bond, from there we are supposed to number. So this compound will be numbered in this way, will be numbered like this. I'm writing it once more: CH3, CH2, CH3, this is CH2, CH2, then CH, then CH3, then finally CH3. So this same thing I'm written again. So I'll number it from here, this carbon, carbon 2, carbon 3, carbon 4, and carbon 5. This is the correct way of numbering. Why this way? Because I have to keep in mind that the methyl group which is branching from the second carbon atom is closer to this terminal carbon atom. So after numbering, we see that there are 5 carbon atoms on the chain. The chain has how many carbon atoms? Tell me. The chain has how many carbon
Five.
atoms? It has 5 carbon
So
atoms.
Five
So
five.
carbon atoms.
5 carbon
So
atoms.
we won't
So
count the
Five.
upper carbon.
no, we will
So we
not
won't.
count. We will not count this carbon atom because it is a group. It is an alkyl group. It is an alkyl group. It is branching. It is branching the chain into an alkyl group. Okay, so we will not count this carbon. We will not count this carbon atom. Okay, now, what did I tell you? The first thing is what? What is the first thing? The first thing is word root.
Word
The first thing is word root. Are you getting it? The first thing is word root. So for 5 carbon atoms, what is the word root?
Pent.
What is the word root?
Pent.
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 So,
Pent.
so below this word root, I'm writing pent in
Pent.
Ten.
small alphabets. P-N-T, pent. Not pant, okay? Not pent. It is pent. It is pent. After the word root, what is number 2? What is number 2? What is number 2?
Primary suffix.
Yes, it is primary
Primary
suffix.
suffix.
I'll write P suffix.
Primary suffix.
I'll
Primary
write
suffix.
P suffix. S-U-F-F-I-X. Primary suffix. So now, what did I tell you? Primary suffix tells us about what? Single bond, presence of single bond, or presence of double bond, or presence of triple bond. No. Now watch very carefully. All these carbon atoms are linked to each other by what? How many bonds? Single bond. No. This one is a single bond. This one is also a
Single
single
bond.
bond. This one is a single bond. This one is also a single bond. No. Very happily. Yes or no? So what is the primary suffix for all single bond? Have a look over here. For single bond, what is the suffix?
In.
N.
In.
It is N.
N.
So
Ten.
so I'll write N.
Ten.
A-N-E-N. So word root is done. Primary suffix is done. Now after primary suffix comes number 3. What is number
Secondary
3?
suffix.
It is secondary suffix.
Secondary suffix.
Secondary
Yes,
suffix.
wonderful. It is secondary. It is called secondary suffix. Now, what does the secondary suffix tell us about? Tells us about what? Tells us about
Functional
what?
group.
Functional group. Which functional group is there?
Functional.
Now, in this compound, is there any functional group? Is there any functional
No,
group?
sir.
Yes or no? No. There is no functional group.
No, sir.
No, sir.
There is no
No.
functional. There is no alcohol. There is no aldehyde. There is no ketone. There is no carboxylic acid. There is no amide. Nothing. No functional group is there. So this is left empty. We don't write anything. There is no secondary suffix because there is no functional group. Now we come to number 4. That is the prefix. That is the prefix. Now I told you prefix tells us about any other side chain branching. No, any other side chain branching by alkyl groups, which can be methyl, ethyl, propyl, okay, or branching by halogens. Now in this organic compound, what is the branching group over here? What is the branching group called over here? What is this group called?
CH3.
CH3 group. What is the name of this? The name of this group is called, it is called methyl.
Methane.
It is not methane. Methane is CH4. Methane is what? CH4. What is methane? CH4.
CH4.
From this methane, if I kick out hydrogen, one hydrogen atom, then we have a methyl group, CH3 group. So that is the methyl group. Now this methyl group, it is present on which carbon?
Methyl is not possible, no?
Methyl does not exist. It does not exist. But methyl group is possible, theoretically. And this methyl group is not independent existence, no. It is not existing independently, but it is linked to this carbon atom, no, second carbon atom. Yes or no? Yes or no? So now this methyl group, it is linked, it is attached to which carbon of the chain? Which carbon of the chain? Which carbon? Second carbon. So
Second carbon.
in the prefix I write down 2 dash methyl, 2 dash methyl, thus 2 dash methyl pentane. Now finally I write the correct answer like this. Join them, join everything. 2 methyl
Pentane.
pentane, pentane, which is the correct answer. Are you getting it? Are you getting it, my dear
Yes,
boys?
sir.
Okay, now wait.
Yes, sir.
Did you
methyl.
understand?
Sir. Yes, sir.
I will give
2 methyl.
Yes, sir.
2 methyl. Your ears, you have plugged your ears, you know. This methyl group is present on the second carbon, no? That's why 2 methyl. You're not paying attention
A.
properly. You are occupied with something else over there. I can understand from here only. Okay. That's why you're asking how methyl, because you are a cow. Nothing more than that. Okay, now I'll just do one more example. Few more examples. I'll make you perfect in this Iupac nomenclature. I'll make you guys perfect in this Iupac nomenclature. Okay, now before going to the next example, let me explain you about alkyl groups. Alkyl groups. If you look at the first alkane, that is CH4, it is an what? It is an alkane. It is an alkane. If I remove one hydrogen from the alkane, I will get CH3. This CH3 is called methyl group. It is called methyl group, GP group, not gram panchayat, okay? It is called methyl group. Then the next alkane is C2H6, which is called ethane. It is called ethane. From ethane, if I remove one hydrogen, I will get dash, this is the bond, dash C2H5. This C2H5 is it is called an ethyl group, GP, ethyl group. The next alkane is C3H, 3 to the 6 plus to 8. This is called propane. Propane. From propane, if I remove one hydrogen atom, any one of them, then I will get C3H7. C3H7. This is a propyl group. Propyl group, GP. So try to remember these 3 alkyl groups, which are normally given in for class 10. These are the 3 alkyl groups which are normally participating as a branch in the chain of an organic compound. Now we come to the next example by introducing another slide. I'll come to the next example on your screen. Okay, just hold on. Let me get things ready to explain that. I hope Dakshis is paying a lot of attention just now. Okay. Now the next example. Yes, the next example. Are you ready for the next example? Are you ready? Are you ready?
Yes,
Nobody is ready.
sir.
Okay,
Yes,
so
sir.
Yes, sir.
Yes, sir.
on your
Yes,
screen, I am drawing one more condensed structural formula. Condensed, okay. CH3CH, and here I have branched CH3, then I'll put CH2, then I'll put CH, then here I'll put OH, and here I'll put CH3. Okay, so this is the organic compound whose IUPAC name I'm supposed to write. Okay, now watch very carefully now and answer my question. Will I number from the right hand side carbon or the left hand side carbon?
Left hand side carbon.
From
If you are
left
Right
hand
hand
Left
side.
hand
side.
side.
if you are numbering from left hand side carbon,
Left
then you are
hand.
wrong.
right answer.
If
Huh?
if this OH is not there, if this OH is not there, then you are correct. But this OH, it is a functional group is there. The functional group, the presence of a functional group dominates the numbering. So from whichever carbon the functional group is closer, this functional group is closer to this carbon, the right hand carbon. So that's why we number from here. Carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. Wait, just hang on, wait, see. If it was like this, CH3, CH, CH3, CH2, CH2, then CH3. Look at this, right hand side, left hand side terminal carbon. Now this example, you will not number from here. You will number from here. 1, 2, 3, 4, 5. Are you getting it now? Because there is only alkyl group over here, and there is no functional group. And remember, the presence of functional groups, dominates the numbering of carbon atoms from that end to which it is closer. From that end to which it is closer. Am I clear? Am
Yes,
I
Yes,
sir.
clear?
sir.
Okay,
Yes,
so
sir, yeah, clear.
numbering is done of
Sir.
carbon atoms. Yes,
Yes, sir.
yes. Now what is the first thing I told you?
OH was
OH is alcohol. I told you OH is alcohol that time. I told you, no? I told you OH is alcohol. Wait. OH over here. Look at the screen. If there is OH alcohol, if there is CHO aldehyde, if there is CO ketone on, if there is COH carboxylic acid, oic acid. Okay, I'll explain this once more after some time. But let me do this example first, then make things clear slowly. Because teaching IUPAC can be done only by on the spot examples. On the spot. Okay, dead spot examples. So now the first thing over here to be written is word root. Now I'm not going to write word root, I'll just write 1. So for 5 carbon atoms, what is the word root? Tell me, my dear boys. For 5 carbon atoms, what is the
Pent.
word root? It is pent. So I'll
Pent.
write over here, I'll write
Pent.
pent. Pent. Okay. Now,
Pent.
after word root comes number 2, primary suffix. For primary suffix, what will you write? Because all are single bonds. What will you write? For primary suffix, N. So you write N.
In.
A N E. Very good. Wonderful. That means you are learning. You are catching very fast. Next. Number 3 is secondary suffix. Now, what does the secondary
OH.
suffix tell us about?
OH.
OH is there, no? Alcohol is there.
The functional.
Alcohol is there, no?
Functional group.
Yes, that is the
Functional group.
this is the functional group. This is the functional group, and it is an alcohol. So this OH is present on which carbon? Which carbon?
All.
Which carbon?
Second, third,
It is present
second
on
carbon.
second
Second
carbon.
carbon.
So I'll put over here 2-OL.
All.
2-OL. Second carbon containing an alcohol, OH group. After that, I go to 4. 4 is prefix. Now, prefix tells about any other side chain branching, no? So, besides OH, is there any other side chain branching? Which one? Which one?
4.
Yes, sir. CH3.
CH3.
4.
So CH3 there.
Methyl.
And fourth
Yes.
carbon, no? It is fourth carbon. So, I'll write in the front over here 4 methyl. Pent N2-ol. Hold on. Got it? 4 methyl. 4 methyl is the prefix. Pent is the word root. N is the primary suffix. 2-ol is the secondary suffix. Now, hold on. There is one more trick over here. There is one more trick. TRICK, trick. You know vowels A, E, I, O, U. Have you learned vowels?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Now
Yes, sir.
now in the secondary suffix, if there is a vowel like this is a vowel, no? This is O, no? O. Is it a vowel? Is this
Yes,
O a
sir.
vowel?
Yes,
Yes.
sir.
Okay. So if there
Yes,
is a
sir.
vowel, in the secondary suffix, then the last alphabet of the primary suffix has to be dropped. That means this E has to be dropped. It has to be dropped. We don't write in the final answer. So the final name, the final answer IUPAC name of this organic compound becomes 4 methyl 4 methyl
Pen-
pentan
Pentol.
dash 2 all. E is not there. So this is the answer. This is the answer. Am I clear?
Yes, sir.
Am I
Yes, sir.
clear?
Yes, sir. Yes, sir.
Are you
Yes, sir.
sure?
Yes, sir. Clear.
Yes, sir.
Yes,
Are you
sir.
sure?
Yes,
Not,
sir.
Yes.
sir. Why not? Yes, sir. Why not 4-methyl to pentol?
No, we cannot write because these two all no. These two all should be given, should be sent to the secondary suffix. I told you, no alcohols. The functional groups are always written in the secondary suffix. That's why this two all is part of 3. This is secondary suffix. You cannot put 2 in the front over here. Are you getting it? Please follow systematically. First word root, then primary suffix, then secondary suffix, then only prefix. Okay. Now, just a second. Let me introduce one more slide to make things much more clearer now. Okay. Much slowly the things will become clearer and the sky will become clear. All the clouds will be removed and then the rainfall will stop. Then it will be a bright sunny day. Okay. So slowly let us discuss. If there is an alcohol in an organic compound, then you will see that groups like this are present. OH. Okay. And when groups like this are present, then in the name, in the secondary suffix, you have to write OL, all. Okay. So these are the functional groups. First one. If there is an aldehyde in the organic compound, then you will find groups like this: CHO, 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 and CHO is also written this way, another form: CH double bond O. This is also CHO. And if there is an CHO group, then in the secondary suffix we write it as AL, AL. You have to be very careful. If you make a small mistake between A and O, finish, wrong, 0. Okay. Then number three, if there is a ketone, nail polish, remember? Nail polish, remember, contains ketone, acetone. So if there is a ketone, then you will find groups like this.
Yes,
Yes,
sir.
sir.
You will find groups like this. CO group. You will find this group. Okay, CO. If there is a ketone, then in the secondary suffix you write ONE, on, not one, okay, on. Acetone, propanone, butanone, and so on. Number 4, if there is a acid, if there is a carboxylic acid in the organic compound, then you will find groups like this. You will find groups like this: COH, or the structural formula, open one, it is like this: COOH. This is also one formula. So if there is a carboxylic acid, then you in the secondary suffix you'll write oic acid. You'll write what? You'll write oic acid if there is a carboxylic acid. So these are the
So,
functional groups.
so that O, so that H, so this carboxylic acid, no, sir. So
This
that
is,
H can be below O and above O.
yeah, it can be up here also, it can be below also. This is the bond, carbon, double bond with oxygen, and single bond with oxygen. This oxygen linked to the hydrogen. Okay, so that is, if there's a carboxylic acid, then the secondary suffix becomes oic acid. Am I clear? So I will stop my class. I would like to end my class here only. Okay, please revise all these things. Otherwise, in the next chemistry class, you'll be lost. Revision
Thank
is
you,
very
sir.
important. Okay, so wait, don't thank so early because I have to take the attendance also. Attendance is very important.
Yes, sir.
Then only you leave the class. Otherwise, you lose your
Yes, sir.
attendance for today.
Okay, sir. Okay, sir.
Sir.
Thank you so much.
Sir.
Thank you, sir.
The attendance list is being downloaded. Okay, it is now downloaded. You may leave the class.
Bye,
Thank you so
sir.
much. Have a nice day.
Bye bye, sir.
So we can go